Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Today we are going to continue with class 9 science chapter number 3 current electricity. Topics that I am going to cover during this session are resistors in series and parallel, as well as we will solve the examples based on them. Resistors in series. As shown in this circuit diagram, there are three resistors R1, R2 and R3. They are connected so that they follow one after the other in a single line. So, these resistors are said to be connected in series. In such an arrangement, the same current will flow through each resistor. But the potential difference across the three resistors will be different. That is, across the resistor R1, the potential difference will be V1. Across R2, it will be V2. And across R3, it will be V3. So, the total potential difference will be equal to V1 plus V2 plus V3. So, when the resistors are connected in series, the potential difference gets added. So, we get the final potential difference V is equal to V1 plus V2 plus V3. And from Ohm's law, you already know the formula that V is equals to IR. So, V1 is equals to IR1, V2 is equals to IR2 and V3 is equal to IR3. Over here, you can see the current is same. As we know, the same current is flowing through all the resistors. So, current will be I only, but resistors are different. So, it is R1, R2, R3 and the potential difference is also different. So, it will be V1, V2 and V3. If only one resistor R is connected in the above example, then the potential difference will be V, that is V is equals to IR. But over here there are three resistors R1, R2 and R3 and three potential difference V1, V2 and V3. So from this first, second and third equation, we can conclude that the total voltage is V1 plus V2 plus V3, that is equal to IR. And IR for different resistors is also different. That is, total IR will be IR1 plus IR2 plus IR3. Taking I common and you can cancel it on both the sides. So finally, we get R is equal to R1 plus R2 plus R3. So when resistors are connected in series, the total resistance in the circuit is the sum of all the resistors. In this case, there are three. So, R1 plus R2 plus R3. If there are n resistors, then total resistance is equal to R1 plus R2 plus R3 till Rn. Resistors in parallel. Resistors are said to be connected in parallel when their ends are connected at both the sides, as shown in the figure. Over here you can see there are three resistors R1, R2 and R3 and their ends are connected together at the point C and D. The potential difference between the 2 points C and D is V and the current I is flowing through the circuit, but through these three different resistors the current will be different. That is I1 through R1, I2 through R2 and I3 through R3. So from Ohm's law, we can get the formula for current. That is I1 is equals to V upon R1, I2 is equals to V upon R2 and I3 is equal to V upon R3. Here you can see the voltage is same because the potential difference between the 2 points is same across all the three resistors. When resistors are connected in parallel, you can add the currents. That is, the total current will be I, that is equal to I1 plus I2 plus I3. If only one resistor was connected in the above example, then the current would be I is equals to V upon R. But over here there are three resistors which are in parallel, right? So we have three different currents, I1, I2 and I3. So from first, second and third equation, we get the final equation as I1 plus I2 plus I3, that is equal to V upon R. And placing the values of all the three currents from this equation, we get V upon R, that is equal to V upon R1 plus V upon R2 plus V upon R3. Taking out V common from both the sides and we will cancel it. So finally we get the formula as 1 upon R, that is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. When the resistors are in parallel, the inverse of the effective resistance is equal to the sum of the inverse of individual resistances. So, when the resistors are connected in series, then the equivalent resistance will be equal to the sum of all the resistance. Whereas, if the resistors are connected in parallel, then the inverse of equivalent resistance will be equal to the inverse of each resistance. And in series, the current is always same through each resistor. Whereas in parallel, the voltage is same across each resistor. Let us solve few examples. Example 1. Three resistors having resistances of 15 ohm, 3 ohm and 4 ohm are connected in series. What is the effective resistance in the circuit? The value of all the three resistance are given. For effective resistance, we need to just apply the formula. Here they are connected in series. So the effective resistance will be the sum of all the resistance connected in series. Here there are three resistance, so we will add the value 15 plus 3 plus 4. That comes out to be 22 ohms. So the effective resistance in the circuit is 22 ohm. Example 2. Two resistors having resistances of 16 ohm and 14 ohm are connected in series. If a potential difference of 18 volt is applied across them, calculate the current flowing through the circuit and the potential difference across each individual resistor. Okay, so here two resistors are there. One is of 16 ohm and the other one is of 14 ohm. They are connected in series. So we have R1 and R2 values. Final resistance, that is the equivalent resistance, will be the sum of two resistances, that comes out to be 30 ohm. Now, let the current flowing through the circuit be I and the potential difference across it be 18 volt, which is given, right? So over here the voltage will be different, that is V1 and V2 across the two resistors, that is R1 and R2. So the total potential difference will be equal to V1 plus V2, and that is given 18 volt. It is the total voltage, but still we don't know what is the value of V1 and V2. In order to find that, first we need to find out the value of current flowing through the circuit. So let us apply the formula. According to Ohm's law, V equals to IR. So from that we can get the value of current I, that is equal to V upon R. We know the total voltage, that is 18 volt, upon resistance, that is the total resistance 30. So 18 by 30 we get 0.6 amperes. So the current flowing through the circuit is 0.6 amperes. Now from this we can easily find out the values of two voltages, that is V1 and V2. Putting in the formula, V1 is equals to I R1 and V2 is equals to I R2. We just have to put the values and we will get the answer. So over here V1 is equals to I R1. So I is 0.6 and the value of first resistance is 16. So we get the value as 9.6 volt. Similarly, V2 is equal to 8.4 volts. So the current flowing through the circuit is 0.6 amperes and the potential difference across the two resistances, that is 16 ohm and 14 ohm, are 9.6 volt and 8.4 volts respectively. Solved examples for the resistors in parallel. Resistors having resistances of 15 ohm, 20 ohm and 10 ohm are connected in parallel. What is the effective resistance in the circuit? So we have the value of three resistances as R1, R2 and R3, which are 15, 20 and 10 ohm respectively. Now you know very well that when the resistors are connected in parallel, then the inverse of effective resistance is equal to the sum of inverse of individual resistances, that is 1 upon Rp. Rp means resistance in parallel. That is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we have all the three values. 1 upon 15 plus 1 upon 20 plus 1 upon 10. Solving it, we will get the answer as 4.615 ohm. So the effective resistance in the circuit is 4.615 ohm, which is less than the list of the three. Right? That is 10 ohm. It is even less than all the three resistors which are connected in parallel. Next example. Three resistors having the resistances 5 ohm, 10 ohm and 30 ohm, they are connected in parallel and the potential difference of 12 volt is applied across them. Obtain the current flowing through the circuit and through individual resistors. What is the effective resistance in the circuit? So the given values are R1 that is 5 ohm, R2 that is 10 ohm and R3 that is 30 ohm. These are the three resistances and the total voltage is given, which is 12 volt. Over here the voltage will be same across all the three resistors as they are connected in parallel. Only the difference will be the current flowing through each resistor. So from the Ohm's law, we get I1 is equals to V upon R1, I2 is equals to V upon R2 and I3 that is equal to V upon R3. So we have all these values, right? So putting up these values, we get the value of three different currents, that is I1, I2 and I3 as 2.4 amperes, 1.2 amperes and 0.4 amperes respectively, right? So in order to find out the total current, we need to add all the three currents, that is I1 plus I2 plus I3. So the total current is 4 ampere. Now we also need to find out the effective resistance in the circuit. So the formula for that is 1 upon Rp, that is equals to the inverse value of all the three resistors, right? So when we will put these values, we will get the value as 1 upon 3, right? So the value of Rp will be what? 3 ohms. So the effective resistance in the circuit is 3 ohm and the current flowing through the resistance 5 ohm, 10 ohm and 30 ohm is 2.4 amperes, 1.2 amperes and 0.4 amperes respectively. But the total current that is flowing through the circuit is 4 ampere. This is all for today's session. Thank you so much.